Hello students, welcome to Unlocking Physics. Today I am going to take you on by a surprise. You know, electric potential is a scalar quantity, but electric potential gradient is a vector quantity. You'll ask, why ma'am? What is potential gradient and why is it a vector quantity? Yes, have patience, we will move on to the board. The relation between electric field vector and electric potential. I am writing all these things by symbols to save time and space. So I am going to express electric field as gradient of electric potential. What is electric potential? You know it. What is gradient of electric potential? That you will be discovering in this particular episode, so stay tuned in. So we consider a situation, plus Q charge kept, and from it at some distance we take 2 points A and B. The electric field direction from plus Q is radially outwards. All these things you have already seen in the previous episodes. The F repulsive force, I have represented it by REP, repulsion. You can even write it as F electrostatic. So the electrostatic repulsive force is in the direction of electric field, pushing the charge Q0, which is kept at A, away from the source charge. So electric field radially outwards, F repulsion radially outwards, that is in the direction of electric field. And we have 2 points A and B. For your convenience, I have shown you at some far off distance, but actually they are very close. And a charge Q0 is kept at A. This distance dr, we want to bring this charge Q0, we want to shift it from A to B. For that, we have to apply F external. All these things again we have seen in the previous episodes. If you haven't seen them, just refer to them. F electrostatic should be in the direction from A to B. That is, it is in the direction of dr against F repulsion. So we are moving the charge with constant velocity. So repulsive force, F repulsion on charge Q0 is equal to E into Q0. What is the direction of this force? It is along the electric field. Small work done in shifting the charge from charge Q0 from A to B. Work done, the force applied into dot product of force and displacement. The applied force is F external because F external brings it in from A to B. And it is against F repulsion. These things are clear from the diagram. So F external dot dr. Here I get F external dr cos 0. Why? Because external force and dr vector, the direction in which we are moving is, they both are in the same direction, they are parallel, angle between them is 0. So we get F external into dr, cos theta is cos 0. But I get a negative sign here. Why this is so? Because you can obviously see dr is decreasing, means final value of r is less than initial value of r. You are moving in the direction of decreasing r. So dr being negative, you get minus F external. Remember one key thing. If instead in some books you will find F external, instead of F external, if you use F repulsion here, no problem. F repulsion dot dr, you can use it. But here the direction of F repulsion and dr will, the angle between them, this will give you theta equal to 180 degrees. And they are anti-parallel to each other, and then also you will end up getting the same negative sign. So it's up to you, but whatever you're doing, you must understand the steps and then only you should follow. So you get small work done is F external dot dr, and F is nothing but minus Q0 E dr. This is dw. If I put dw upon Q0, I am left with minus E dr. What is work done upon charge? It is nothing but electrostatic potential, small potential dV. It is minus E dr. I can write it as E is equal to minus dV by dr. This is our special term, dV by dr, rate of change of potential with respect to distance. This term gradient is already introduced to you for various concepts like velocity gradient, temperature gradient. So here it is potential gradient, variation of potential with respect to distance, and it is the expression of electric field. Electric field is expressed as gradient of electric potential. Now what is the significance of negative sign? What is this negative sign signifying here? First and foremost thing, direction of electric field is in the direction of decreasing potential. Means if you are given the direction of potential, you can find the direction of electric field. What is the direction of electric field? It is the direction of decreasing potential. You know, potential, suppose here it is at V1, here the potential is V2 and V3 and so on, and obviously V1 is greater than V2 is greater than V3. Why? Because the closer you move towards the charge, you get potential value, because you know that V is equal to KQ by R. The less the value of R, more will be the value of potential. So the closer you move to the charge, more will be the value of potential. So V1 is greater than V2 is greater than V3. And what is the direction of electric field? Yes, it is in the direction of decreasing potential. The direction of electric field is in the direction of decreasing potential. This is indicated with the negative sign. Second thing, E is equal to minus d V by dr or E dot dr. This can be written as E dot dr. Dot product of electric field is a vector quantity dr. The space element is also taken as a vector quantity, and E dot dr is equal to dV. This is valid even for non-uniform fields also. It is valid for non-uniform fields also. And third important point, you need to get it registered in your mind, dV by dr. This is potential gradient and it is a vector quantity. Potential, this V is a scalar quantity, but dV by dr, potential gradient, is a vector quantity because it is equal to E, and E, electric field itself, is a vector quantity. So potential gradient is a vector quantity even though potential is a scalar quantity. I hope you are clear with the concepts. This particular formula, this gives you the SI unit for electric field as volts per meter, and a very, very significant formula for numericals, reasoning based questions, conceptual questions. And it is a very, what you can say, important segment from this chapter, from the CBSE also prefers to ask questions. So just go through it. If you have any doubts, you can put them in the comment box. By that time, thank you. Goodbye.